Okay, well, welcome to our introduction to radical functions. So we're talking about the function, the parent function. That means there's no shifts or changes. This is the function y equals the square root of x, or radical x, you can say. That's why they're called radical functions. And the graph kind of looks like this little radical figure right here. So things to think about. First, we're going to look at it from a graph. All right, we're going to list out some important points, and then we're going to talk about the domain and then the range. Okay, so first of all, some important points right here would be 0, comma 0, right? 0, comma 0. And then the next kind of important point that you could say is 1, because the square root of 1 is 1. So you could say 1, comma 1. And then that exists right here. And then you could say the next kind of point of interest would be 4, comma 2, because the square root of 4 is 2. Right, and then if we have it on here, the square root of 16 right here is 4, and then also the square root of 9 is going to be 3. So those are some important points that are on this radical graph here. So as you can see, the domain is all the x values here. So you see it starts at 0 and then just goes on forever in that direction. So you'd say the domain is x is greater than or equal to 0. That means all positive numbers. And then if you look at the range, you can say, well, the range in this particular case, since it starts at 0, you're going to say y is greater than or equal to 0, right? So it's going to be all positive numbers because the graph just keeps heading off up towards infinity in the direction to the right. Okay. Now let's look at something else. The next function here. If we look at the function right here, y equals x squared minus 9. So list out some important points here. So some important points here you can see would be negative 3 comma 0. And then another one over here would be positive 3 comma 0. These are 2 points that are kind of very important because it's where the graph hits the axis. And you notice the graph doesn't really exist in the middle, like in between the two like branches of the graph here. The graph doesn't exist between here. It kind of comes down and then it just jumps and then keeps going up if we read from left to right. So the domain of this function, right, it's going to be all numbers. X is going to be all numbers less than negative 3 and all numbers greater than positive 3, right? We can't plug 0 into this function. Can't plug negative 1 or 1, right? So you could say the domain is that, excuse me, has got to be x has got to be less than or equal to negative 3, and x has got to be greater than or equal to 3. Okay, so there's a couple of different ways to write that notation. Okay, this is totally acceptable for us. And then if you look at the range here, you determine the range here. This goes on forever in that direction and then forever in that direction. So in this case, y is also greater than or equal to 0. Okay, because the graph never goes below 0, right? Never goes below 0. It just remains at 0. And the outputs will always be headed up towards positive infinity. Okay, so these are 2 ways to graph to find the domain and the range of radical functions. Okay, now we're going to take a look at the algebra behind finding the domain and range. Okay, so if I take a look at this, what we've noticed here is underneath this radical right here is a simple expression. It's x minus 5. So what we need to think about is we can't take the square root of a negative number and get a real solution. Okay, so this can't happen. All right, so what we can do here is if I just take this x minus 5 and write a little an equation and say, well, where is x minus 5? That's got to be greater than or equal to 0. So if I solve for x, add 5, add 5, I'm going to say x is greater than or equal to 5. So that's the domain of this function. And then the range of this function, right, is going to be all values that are greater than 0, right? So y is going to be greater than or equal to 0, right? Because you can't possibly get a negative number out for our square root, okay? You can't possibly get a negative number out if we're taking the square root of a number, okay? And then the last little bit here is algebraically find the range of this function. Now we have a quadratic underneath the radical right here. So again, remember this can't be negative. So I'm going to say x squared minus 4x minus 5 has got to be greater than or equal to 0. So the first thing that interests us is what values make this equal to 0. So this is where our techniques come in. We can GCF, we can dots, right? In this case, we've got this, x minus 5 and then x plus 1 are greater than or equal to 0, okay? Meaning that we know, if we looked at kind of like a number line, we know that the number 5 is important because that's what makes this 0. And then we also know that the number -1 makes this important because we know that it's equal to 0. So now, if it's equal to 0, we need to check what happens along this number line here. So the best thing to do is choose the easiest number to substitute in. So for the easiest number for me to substitute in, I would substitute in 0. So if I go and substitute in 0 into this equation, I'm going to get 0 squared minus 4 times 0 minus 5, right? So I've got g of 0 is equal to, g of 0 is equal to -5. So we know that anything in here between these two are going to be negative, and it's going to be positive over here and then positive over here. So if we want to find the domain and the range, okay, we can say, well, x is got to be less than or equal to -1, and x is got to be greater than or equal to +5. Okay, so there's different types of notation, the way to write this down. This is totally acceptable, the way to write this down for the domain, okay? And we can see that this is a radical function. There are no shifts to it. So our range here is going to be y is greater than or equal to 0, right? You can't get a negative number out. If we want to look at a table here, the table kind of helps this make sense. So if I look at x squared minus 4x minus 5, and then you go ahead and then look in your calculator, I'm going to put it into the calculator, x squared minus 4x minus 5. If I click on the table, you can see here that the outputs here are negative, right? Once it hits -1, then it's going to drop down. Now our outputs are negative, -5, -8, -9, -8, -5. And then back to 5, it gets 0, and then it becomes positive again. Okay, so that's one way to kind of tell, one way to kind of look at it, right? If you even look at it at a graph, you can look at it at the graph here. Well, my graph is a little zoomed out here, but you can see here that these are the 0 points right here. That's the 0 point, right? And then you slide over. There's the 0 point. So this is where all the negative numbers are. And you can't have negative numbers underneath a radical. So that's why we can do a test either like this, where you just lay out the number line, or you can check your calculator and throw it on the table and determine where the function is negative, okay? So in short, radical functions, right? Radical functions, right? We've got y equals the square root, all right? Whatever is underneath here, right? This cannot be negative. We cannot get a real number solution if anything under here is negative, right? And this is what represents the domain. And in general, the range for most radical functions are y is greater than or equal to 0. Okay? Hope this helps. Good luck, and I'll see you all soon.